Learning new mathematical knowledge can sometimes be challenging for students. Even when mathematical knowledge is a building block to elaborating great theories, some concepts remain abstract. The abstraction can reside in the fact that mathematical knowledge can sometimes have multiple personalities. Like a coin, knowledge can be two-sided, heads or tails. Let's use finding the average as an example. What is the average of a distribution? Some will say, the central value in a set of data. Others will say, it's the sum of data divided by 8. They are all correct. Finding the average, like many mathematical knowledge, is both a concept and a process. Concept, mental representation of an object or idea. Process, ordered chain of operations leading to a result. Sometimes a concept like in measure of central tendency, sometimes a process like sum of the data of a distribution divided by the number of data. It's the same for a proportion in arithmetic, a line in geometry. As teachers, we want students to consolidate new knowledge as we introduce it. But how do we do it? Many mathematicians suggest introducing new knowledge to students following the 3N approach. The 3N approach recommends introducing new concepts first. Then, once the new concepts have been introduced, we start asking questions that will lead to new processes for problem solving. Finally, to consolidate the knowledge, we introduce new contexts to mobilize the new concepts and processes. To summarize, Step 1. Test the concept by asking questions with action verbs such as state, identify, classify. Step 2. Test the process by requesting tasks with action verbs such as calculate, deduce, carry out. Step 3. Ask questions in context using action verbs such as explain, justify, analyze. For steps 1 and 2, you can use real or purely mathematical situations. For step 3, we strongly recommend that you use authentic contexts. Real or purely mathematical situations are often meaningless and simply require the application of mathematical concepts and processes. Authentic contexts are real and meaningful situations that require decision-making through the mobilization of mathematical concepts and processes. In closing, we strongly suggest you plan your assignments using the 3N approach. Especially for students who have a hard time with mathematical abstraction. This approach, both sequential and progressive, lets you quickly target the difficulties that students may have with certain mathematical knowledge and to intervene as needed to overcome them.